Welcome back. This is still Geometry, Unit 3, Section 3.1, Parallel Lines Being Cut by a Transversal. This is video 4 of 4. Going to finish with two more examples where we're writing equations inside of this parallel lines being cut by a transversal scenario. Again, at the heart of the question, if you can identify what types of angles you have, you can write an equation to match it, and you can solve that equation while justifying all your work. So inside of the first question are two angles that give us our angle 1 and angle 7. Notice how 1 and 7 are on the same side of the transversal and they're on the exterior of the parallel lines. Therefore, they're same side exterior angles, and when two parallel lines are cut by a transversal, the SSEAs are supplementary. So I'm going to have 2t plus 20 plus 3t plus 10 should equal 180 degrees, because same side exterior angles theorem, or instead of theorem you could write are supplementary. Again, you have the liberty of either writing the actual statement, the fact, or the name of the fact. Okay, when I start to solve this, looks like we have a lot of things to combine on the left side. You don't have to draw the line down the middle of the equation. I kind of like to. Actually, this might be a good time to remind you that we are writing a two-column proof. So I'm actually going to draw a line in here where we have our conclusions and we have our justifications. Okay, so next step, I'm looking at the left side of the equation. I see the 2t and the 3t. I'm going to put those together to make 5t, and the 20 and the 10, I'm going to put those together to make 30. So I have 5t plus 30 equals 180. And if you recall, there's lots of ways to justify that. We could write combine like terms. We could also say simplify. Or you could also say substitution property of equality, because I substituted in 5t for 2t plus 3t. Or I substituted in 30 for 20 plus 10. Okay, continuing to solve. I would take away 30 from both sides. So 5t equals 150. And since I subtracted something from both sides, that'd be the subtraction property of equality. Divide both sides by 5 to get t equals 30. And what did I do to both sides? I divided, so therefore the division property of equality. And I also strongly recommend taking some time plugging that value back in and making sure that those values are actually equivalent. Okay, last example, I have an angle in 2y plus 20 and 3y plus 30, so this angle here and this angle here, they are on alternating sides of the transversal on the interior of the parallel lines, therefore they are AIAs, alternate interior angles, and those are congruent. So 3y minus 30 should equal 2y plus 20, since AIAs are congruent. So there's my justification. Alternate interior angles are congruent. Then I start to solve. I subtract 2y from both sides. So y minus 30 equals 20. That was subtraction property of equality. And then I add 30 to both sides to get the y by itself, so y equals 50. And again, what did I do to both sides? I added, so that'd be the addition property of equality. So as long as you can identify what types of angles you're working with inside of the parallel lines being cut by a transversal, you should be able to write your initial equation, and then you should be off and running.